Hi friends, welcome back to Mule 4 series of learning videos. I am siva.thankamanee, an integration technical architect. From yesterday, we have started integration design pattern series of videos. So as a continuation, we are going to see guaranteed delivery today. Let's get started. We all know that integration design patterns attempt to address specific problems in each of the design pattern. So here in the guaranteed delivery, there is a specific problem being addressed. Let's see what this is. The problem statement here is when we are receiving the critical messages like transactional messages, for example, order management system, employee provisioning system, where we retrieve the details of the employees and details of the order, that is hard to reproduce for the second time since it's transactional, and by missing which we will be losing the precious data that we will not be able to refer it back. So normally for the transaction mechanism we will be using message queues like JMS or any point MQ or any other messaging system. Even database can be used as a persistent mechanism in order to store the data before we process it. However, the problem is even when we store it into the JMS queue or any point MQ or database, it's always subject to communication failure. So in such cases, there should be a persistent mechanism even when the application crashes or messaging system crashes or the database is completely out. Then we should have a 100% reliable mechanism to those messages back so that we will be able to reprocess it and make the lost messages available forever. Let's see how we can make this solution to make this persistent and make the data available even when the messaging system crashes or when the database communication fails. Let's get started with the demo. So we created a Mule 4 flow, and we are going to add a HTTP listener and the basic transformation as usual. So let's drag and drop HTTP listener and transform message. Basically it gives some success message. And so we will be configuring this HTTP listener. Let's say the resource path is guaranteed delivery demo. Let's run this. Started now. So let's choose guaranteed delivery demo. Let's run this. So we got the success message. So now we are going to see step by step on how we are going to introduce messaging system and then how to make it persistent. Now let's introduce a messaging system, because we are going to consider this entire transaction as a critical one when we are doing it for like online orders or employees provisioning system or payment transfer. So let's consider this is critical transaction. So that's why we need a messaging system. So we are going to use JMS, and we need to publish as soon as we receive the message so that we don't lose the message. So let's go with the publish. And after publish, always we are going to say output success, and we are going to say message and request received. It will be processed later. So you have some kind of acknowledgement mechanism so that user knows that request is received without any issues. So let's go to the JMS, and we need to create a connector configuration. Let's do that. So we have already started this ActiveMQ server, and this is the TCP connection which we can copy from here from the console log. And so we have created a queue called employee, and first let's create the connection. So we will add a dependency, and then we will add a factory configuration edit inline. And once we get it, we have to give broker URL whichever we copied, which it has the host and the port name. And that's pretty much it. And we need to give username and password. We are going to say admin and admin. We will test the connection. So that the connection is successful, which means we are able to make connection to the JMS. Let's save this. And we are going to give a destination name as a queue. So let's choose, let's open this web console. Web console is this one, 8161. Let's go back. Let's say HTTP localhost 8161. This gives us, will manage the ActiveMQ broker, and we will go for queues. And there we have employee. So employee is a queue, which we have to mention it here. And that's pretty much it. And so let's demonstrate and see whether the messages are available or going into the JMS queue. Let's save this. Since we have introduced, I think we might need to restart the application since we introduced JMS configuration. I'll pause the video for a while until the application gets started. The application is started now. Let's go back and let us form the message. So we are going to form the message 1, and we are going to run. So it says status success and request received. It will be processed later, which means the JMS publish has been successful. So so we don't see any error. Let's go back to the. So now you can see the message is published, and by default ActiveMQ uses the correlation ID with the same Mule4 correlation ID. You should be able to see this in our log. You can see here. And we are not displaying any log in order to make this correlation ID visible. So let's introduce this logger. So we are displaying the correlation ID. So let's invoke this again, and let's call it as 2. Let's call it. Now let's see what the messages are there in JMS. Now you can see there is a second message stored, which is this one, and we should be able to see this in the logger. You can see here this is the correlation ID. The same is displayed here. So the JMS uses this correlation ID as a message ID by default when it is storing the data temporarily, because we have not published, we have not consumed these messages yet. So let's introduce this message consumption. So slowly we will come to the topic for integration pattern on how to make this persistent. I'll get to that later. So now we are going to introduce JMSListener. So we have done the publish part. Now we need to listen those messages, retrieve it, process it. So let's do that now. And so listener configuration, we will make it. And we need to ensure that we are using the same destination employee. So the consumer type is Q consumer. And automatically everything is configured. You don't need to do anything. So that's the beauty of integration tools. Everything is configured, unlike you are doing it in Java J2E applications. So we will receive the message and then we are going to write it into database. So let's insert into database. And for database, we will have the configuration. And we will choose MySQL. That is what I have it in local. So let me configure Maven dependency. And localhost root and root. Sorry, port should be 3306. And password is also root. And database is employee. So let's test this connection. I think we have brought the server down. Let's start that. It's running now. So now we will test the connection. Connection is successful. So I have a table called JSON where we can store data. So I have created it already. So I'm going to introduce a simple SQL insert into JSON. And values, we are going to say data. So we are going to store, retrieve the payload, and then we are going to store that received payload as is without doing any manipulation, since it's a demo. So let's decide what the data is here. And we have seen already how to do that. So we will say data, and we can say payload. So whatever we receive here, we will put it into the database just for demonstration purpose. So we have done it. So we received the data and then we insert it into the database. So that's it. And it's erroring out. I think since we have introduced database configuration, we need to restart the application. There is some error that's showing in the JMS. Oh, we didn't choose the connector. Sorry about that. Let's save this. And it started. Now let's try this. So we will give now message 3 and run it. It's successful. Let's see whether the data has been inserted into the database successfully. Let's go to the database. So since we have the listener, we don't need to trigger anything. It should automatically consume the message and insert that data into database. So let's go back and then let's choose it. So we need to have the message. Let's delete the content and let's do it from the beginning. So there is nothing. So let's do that, attempt it again. So message 3 should be there. Let's see what is there. So now you can see a junk character. We have already seen that it's taken as a Java object, which we need to convert it into a string. So we have already seen in many previous videos on how to do that. So now we need to convert that payload by using write payload, and let's treat it as application JSON and close the write method. Save it. Now it should restart and then it should work fine. Now let's go and introduce message 4. Let's run this. It's successful. Let's go to the database and then run it. Now we can see message 4. Now it's time to investigate what is there in the message queue. And let's go to the queues section and let's choose employee. And you don't see any pending messages because all are consumed and processed successfully. And let's go to queues. So now let's come back to the topic that we are discussing about. It's an integration pattern about guaranteed delivery. So what if this messaging system fails? For example, the ActiveMQ server is gone down intermittently. So at that time, we should be able to make these messages available for us to refer it back. So there are several steps to achieve it, and we are going to do this first step. Let's go here, and let's open this JMS configuration. And we are going to make one slight change here, and in order to do this publish configuration, we are going to make a persistent delivery to true, and the time to live is, so we are going to say like say 5 hours, because sometimes intermittent connectivity can happen. It can't last for 5 hours, but we are trying to give maximum possible time, worst case, and that's it. So we now made it persistent. Now it's going to make a slight difference here, and we saved it. Now let's try it. Now let's try with message 5 at this time. Let's try. It's successful. Let's go back and investigate the database, and message 5 is available. Now let's go back to the ActiveMQ server, and then let's refresh the queues. Let's make one more changes in the listener, and in the listener also we are going to say the persistent delivery is true, and then time to live we are going to say 5 hours, and we will save this configuration, and let's wait for the server to restart, and then let's try with another message, say 6. Let's run this now. Let's go back and then so now what we are going to do is in order to, because since it's consumed already and then successfully it reaches the database, we are not able to see that. I wanted to show you some specific things when things are failing here. So we will bring down this database server. So we brought down, and we will run this again with 7. Try this. Now it should have failed here because of this connectivity error. Now you can observe here, since this is failed, you can see there is a dead letter queue created because of this failure, and then you can see if you click on it, this is made persistent because it's avoiding in case there are errors occurred. So we can click that, and you can see the message 7 got persisted. So this is this is like plan B. When something happens, the message is persisted. So even if the server crashes or sometimes we revisit, this message will be made available for 5 hours at least from the minimum time to live. So this is one of the method where we can make sure that these messages are available for us to refer back when something happened, or when messaging, or when the database mechanism fails. So now what we are going to do is we are going to make another layer of security in case something is failing. Let's do that. So let's use this try catch. We'll use try, and we will insert the database. And in case of errors, what we are going to do is we are going to use object store, and we are going to store the messages that got failed into this object store. Let's drag and drop this. So we will put error handling. So on error we need to propagate, and we are going to introduce object store. So we are going to configure this object store here. Let's configure by choosing this object store and say plus, and instead of object store we will say employee store, where we are going to store the failed messages here. So when you are using object store, you need to be very careful, because if it is on-prem server, you don't need to worry about the limit, because you know the server capacity well. But if you decide to deploy it in the Cloud Hub, you need to make sure this max entries are filled in, because always the Cloud Hub has some limited infrastructure based on the vCore size. So let's choose 100. Let's not flood it with thousands of entries. So entry time to live is again 5 hours. We will give not more than that. So let's say OK and save this. And we need to store this message into the key. As a best practice, we should always use correlation ID. So let's use correlation ID here. So now we have introduced plan B for plan B. So it's like a second layer of protection, where even if that fails, messaging also fails, you can still rely on object store. So we are going to store this here. Let's save this. And again, since we have introduced the object store configuration, we need to restart the server. Application. There is some error. Okay, it's complaining that the database connection still not achieved. So let's ignore that and go. And let's add the message 8. And it's successful, but internally it should have failed. And now it should have been available in the object store. So now object store is very useful for us. For example, if you feel there is a definite failure, and then if you feel there are some 30-40 failures available in the object store, then you can create your own HTTP listener or API where you can process those messages that are available in the object store. That's the power of object store which can come handy. So let's introduce HTTP listener. And so in this listener, what we are going to do is we are going to retrieve the content of object store. I mean, obviously, whatever messages failed, it should be available there. So let's say retrieve all. And we are going to retrieve all the failed messages, and we are going to visibly see how many of them are there in the object store. So type in object and then choose retrieve all. So this retrieve all fetches all the messages that are available in the object store when you invoke it. Let's choose employee store, save it, and let's use transformation. And let's see what the content is. So let's say payload. So now we are going to see the content by retrieving all. Let's save this and wait for the application to be started. So now we are going to go back, and instead of this demo, we are going to say retrieve all. And don't worry about this message, it should be get method. So it's an empty content, and then now let's try with some failures now. And so we are going to go back and then get the resource path. We are going to copy here, and let's say 9, and let's say 10. Okay, so I think there should be some failures now added into the object store. Now let's say retrieve all and then try. Now you can see here we invoked twice, and you can immediately see the message 9 and message 10 we are able to see. So it stores the message ID, the correlation ID as a key, and the message is stored as a value in the object store. So this comes handy. I mean, when do we use this API? So whenever you know for sure that the underlying issue got resolved, say for example, you got the server up and running, you got the database connectivity resolved, then you can go back and refer this dead letter queue, which is automatically created based on our configuration that it is persistent. Then you can see all the messages here. So this is one layer, and then the second layer you can come here and process and trigger this, and you can so this is strictly used only when all the issues are resolved. And you can introduce to here the processing mechanism. Say for example, you need to iterate all these messages that are taken from object store and possibly insert database operations and then take those messages and insert it into the database at once. So this gives a second layer of protection that it is completely persisting. So finally, once you process, suppose if you decide to process, because right now this this version is only listing out what are the data that are failed. Now you can visibly see, I mean, like if you are the production support team, you can use this service to list out what are the failures, and you can write a separate endpoint where you can process those messages and then insert it into the database. And once inserted, you need to ensure that you are clearing all the data, because so that it doesn't need to process redundantly. So we need to choose data store and retrieve all is used already, and then you need to clear it. So let's drag and drop, and or let's introduce another HTTP listener separately to do that. And let's call this as clear failures, or let's say clear simply. And you will choose clear here, and then we need to choose the object store. You need to choose the corresponding object store, because your application might contain employee store, order store, so you can have multiple entities. So this is to clear, and then you can say transform message and JSON message, say status, failure messages are cleared successfully. So this will come handy once you processed. You can clear them. So let's go here, and instead of retrieve all, we can choose clear, and cleared successfully. So now let us do retrieve all, and let's see what happens. Now it says empty content, so it's cleared. So these are the different mechanisms where we can ensure that your precious data are kept somewhere for later reference without being lost. So that's it in this video. We have seen about guaranteed delivery, but please ensure that you are using this kind of guaranteed delivery mechanism only for the critical APIs, and don't overload very simple APIs with multiple layer of protection unnecessarily. So hope you find this useful and then you enjoyed it, and if so, please hit thumbs up button and subscribe my videos. Soon I will come up with more interesting topics. Thanks for watching. Bye.